So today I'll be presenting on the differences between mediation and moderation. They are tests of distinct theories. They are often used interchangeably, but the whole point of this presentation is to kind of tease out the differences between them and to illustrate some examples. So just a brief overview of what I'll be touching on today. Basically describe both types of techniques, starting with mediation, followed by moderation. And then within those two, I'll be talking about, through the use of examples, theory building and theory testing. So the way that both mediation and moderation work is that you first build a theory about how you think different variables are related to each other, and then you use either mediation or moderation models to test those theories. And the biggest takeaway point of this is that mediation and moderation only test associations between variables, so it's correlational in nature. But since you are building the theory and using your own expertise and background knowledge and everything like this to build a theory, you are making causal inferences. And the fact that the models turn out the way that you predict is confirmation that your theory was right. That's why the theory testing piece is there. So you infer causality, but the models themselves are not actually, designed themselves to test causality. If you have an experiment, certainly that would be part of it, but for a lot of studies, we're only looking at correlational links, so it's important to note that. And then, of course, this feeds into implications for study design and data analysis for some of the reasons that I just described, and I'll be discussing the details of that as we go. But generally speaking, there are issues dealing with how you sample your participants in order to get the maximum value out of these models. There are experimental designs versus observational studies, and data analysis is also done in SPSS as we do in the Chicago School. And so I'm not going to be going into a lot of detail on data analysis, but I will be talking about how to actually put these together. And in terms of specifics, you'll have my contact info at the end, and we can talk about that offline. So let's get started with mediation first. No particular reason, I just talk about mediation first here. In the very sort of basic sense of looking at a connection between two variables, we always start with an independent variable and its correlation to an outcome variable. So you can have it called an independent variable, you could call it a predictor variable, whatever you want to call it. It has some connection to an outcome variable, also called a dependent variable or a criterion variable. All these terms are used interchangeably. But the point is that there's some link between them. And here you'll see there's an arrow, right? And the reason that there's an arrow is because we presume that the independent variable causes the outcome variable. And we'll look at an example. But for now, just know that there is, some association here, and it comes in the form of a correlation. And again, we infer causality because we use our own sort of knowledge to make that kind of conclusion about the relationship between them, if there is one. And from here, there could be a mediating variable. And what is important to note about this is that there's this path that there are actually two paths that go from the independent variable through a mediator and then into the outcome variable. So it's kind of like this detour, if you will, going around path C, and it goes from the independent variable to the mediator to the outcome. So the idea is that in mediation, you're identifying an intermediary process that leads from the predictor to the outcome. And what that is like I said, kind of a detour. So there are a few criteria that have to be met. The first of which is that this path C must be significant. In the very first place, there has to be a relationship between the independent variable and the outcome variable that can be mediated. If there's no relationship here, there's nothing to talk about. But then paths A and B have to be significant as well, because the mediator has to be related to both the independent variable and the outcome variable for there to be this detour to exist. And last but not least, the strength of this path C must be diminished when the mediator is added in. So basically, this mediator has to kind of take the place of the independent variable as explaining the outcome. And if you have all of these criteria met, then you can say that there is mediation taking place. There is a sort of secondary point I need to make here, which is that the degree to which path C is diminished can vary. And so it can completely disappear, right? In which case you have mediation that's called complete mediation, total mediation. And if it is only diminished but is still there, the correlation is still present after you add the mediator in, then you've got partial mediation. But this is the general idea, is that when you introduce the mediator, you start to explain the mechanisms by which the original correlation could really work. So if you have some theory that, oh, you know, I'm going to say that there's this mediator variable, you have to go in and see whether or not that original link actually disappears once you introduce that third variable. So let me put that in a bit more context by giving an example. This is a study of physical abuse in early childhood and its relationship to violent behavior later in life. So there was previous research that was done that showed that there was this link between early childhood physical abuse and then violent behavior exhibited by those children who were abused. Later in life, they were, you know, the more early childhood physical abuse you had, then the more violent behavior you exhibit later in life. So path C here was known to exist. And then Dodge et al. Theorized that children exposed to physical violence acquire deviant patterns of processing social information. And it wasn't early childhood physical abuse per se that led to the violent behavior. It was this development of deviant social information processing that actually led to the violent behavior. So what they were theorizing is that there was this mediation by deviant social information processing that existed between early childhood physical abuse and violent behavior later in life. And they tested this model and actually found that, yes, indeed, deviant social information processing was strongly related to violent behavior later in life and to early childhood physical abuse. And when you added in deviant social information processing into the model, that this original link disappeared. So indeed, it seemed that early childhood physical abuse caused deviant social information processing, which in turn caused violent behavior. So the understanding of this phenomenon was sort of better understood by way of this study. And so it was we no longer understand this link to be the causal mechanism. It's really more nuanced and more detailed now, because now we know that there's this third variable at play that is actually causing the violent behavior. So we kind of filled in the gaps here a little bit, and obviously this has implications for treatment, diagnosis, and things of this nature. So yes, go ahead.
I have a question. In terms of the relationship, do you also think about the direction of the relationship? In terms of the introduction of the mediator, will that affect the direction in terms of negative or positive relationship between the variables?
Right. So that's a very good question. Thank you. And yes, they have to be positively correlated, more or less. And the way that works is if you had two variables that are positively correlated with each other, so let's say early childhood physical abuse and violent behavior, right? So the more of one you have, the more of the other you then have. You would have to also have a positive correlation between the independent variable and the mediator, because they're theorized to be kind of not the same thing, but if this mediating link is going to be visible, then they have to be related to each other in a positive manner, and the mediator also has to be related to the violent behavior variable in the same way that the original independent variable was related to it. That's how you test whether or not this original link disappears, because these two variables, the independent variable and the mediator, explain the same variance in the violent behavior variable. And if that is the case, then you basically show that they're collinear. And if they're collinear, that's a technical term, but basically what it means is that when you have both of them in a regression model, the shared variance in the dependent variable that they explain is partialed out, meaning that that's what it means to have this link here disappear, because both variables, both the early childhood physical abuse and the deviant social information processing, they explain the same phenomenon, basically. And they have to be positively correlated in order to do that, more or less. Does that answer the question?
Yes.
Okay. Great question, by the way. That's that really gets at the core of how an actual statistical analysis of this would work. But this is much more. This presentation is designed to be much more conceptual. So I think I might do a follow-up at some point of doing this in SPSS. But for now, that would be, that would take more than an hour. So I wanted to not really do too much of that. But great question. Thank you.
Thank you.
Okay, so conceptually, this is kind of going to go over a little bit of what we just discussed, but when you're testing mediation, you have a number of steps that you have to go through, and each of them is basically a regression, a linear regression. And so the first is that you have to confirm that the independent variable is correlated with the mediator, right? Because that's part of the process. And that's path A. So you test that by doing a simple regression, which is just basically, having one predictor and one outcome. It's similar to a correlation, but I should also note that you shouldn't be running these as correlations. It's important to run them as regressions for some technical reasons that have to do with the way that you interpret the coefficients later down the line. But anyway, so the second step is that you have to confirm that the independent variable is in fact correlated with the outcome. That's path C. And lastly, you have to run what's called a multiple regression, where you have multiple predictors. And this is where you have paths B and C in terms of what that means is you would have the mediator and the independent variable predicting the outcome. So two predictors as opposed to just one at a time. So in steps 1 and 2, you only have one predictor at a time, but in step 3, you have two predictors in the same model. And you also enter the variables in blocks, meaning that you have path C, and you look at the effect of the independent variable on the outcome variable. And then you add in path B in a second block, and the output basically shows you, okay, so in block 1, path C has some strength associated with it, and it has a p-value associated with it. And then when you add in path B, it shows you, okay, well now once you've added in path B, here's what path C looks like, and it also has a strength and a p-value associated with it. And what we're looking for is the change in that path C, right? That's what this note here is. This C prime. That's what we're looking for, is that change in path C. And when you have both of those pieces of information in place, then you can determine whether you had partial or full mediation of the original relationship. So when we're looking at this full or partial mediation, it's important to note that there is an actual statistical test of whether or not that change in path C was significant, and that comes in the form of the Sobel test. I see there's a question, does this testing mediation work for ordinal regression as well? Yes, it does. So I've been referring to linear regression. It all boils down to a linear model, but yes, if you have an ordinal regression where you have, 2 or 3 different outcomes, which might be, for example, I don't know, let's say age groups, right, where you've got a young group, like a middle-aged group and an elderly group. You could have that as an outcome and still use these same techniques. It's a little bit trickier in terms of interpretation for an ordinal regression, but for a logistic regression, it still certainly holds, yes. Okay, so where was I? Right. Well, before I move on, does that answer the question? Okay, great. Right. So, right, we're interested in finding out whether or not the mediation actually is significant, because you can always have the coefficient of that original correlation between the independent variable and the outcome variable change. But the significance of that change is what the Sobel test is actually going to tell us. And I should note that there are many different versions of testing the significance of the change in path C, and McKinnon et al. Go into a lot of detail on this. But and the reference is going to be all the way, it's the last slide, so we'll see that at the end. But the idea is that if you have a highly significant effect, it almost doesn't matter which version of the significance test you use, because that effect will sort of make itself very clear. But what we're doing is basically getting a z-score. You see that the Sobel test boils down to a z-score, and what we're doing is we're dividing the effect by more or less its variance, and that gives us a z-score, which we then compare to a normal distribution of z-scores. And more or less, if your z-score is greater than 1.96, then your p is less than 0.05. If you go to the back of any stats textbook and look up a z-table, whatever this number is, you can look up the corresponding p-value. You can also calculate it, but suffice it to say that it's once you have all these numbers from your analysis, and SPSS gives you all of this output. And I've listed what all they mean here. You've got the alpha is the path A coefficient, and when I say coefficient, I mean the unstandardized beta coefficient that you get in a regression output. Same thing for beta, that's the path B coefficient, and the sigma is the standard error of each of those, and then Z, again, you calculate that. Anyway, folks much smarter than myself have looked at this, and you can review these articles for a much more in-depth treatment of all of this. But for now, it's just important to know that there is this technique by which you test the significance of the change. So in the example that we were looking at, the correlation between the early childhood abuse and violent behavior would drop, and Sobel's test would be significant, meaning that the drop in that correlation would be significant, statistically significant. Okay, So let's talk a little bit about the theory of all this, right? I keep talking about, causality and correlation and things like this. And I just want to have it here in black and white. And I want to note that, the researcher dictates which variable is a cause and which is the effect, and you build your model accordingly. And then all you're doing with a mediation model is testing that theory, right? So just like in the example we looked at. And that's how you can basically infer causality, is that you are responsible for saying, okay, look, I have an independent variable, and I'm going to say that it causes the mediator for various reasons, including, the fact that one comes before the other, and one has to happen for the other to exist, and so on and so forth. But in reality, what we're looking at in terms of the data analysis is just correlations, right? So those correlations aren't there to tell you that there's a causal effect. The model has to be set up by you in a way that is interpretable by other human beings. And so you have to have, if you're publishing a dissertation or a peer-reviewed study, you have to motivate the model in such a way that people will say, okay, yes, I understand, that makes sense. Right, so there it is, right? The regression or ANOVA only test associations, but the empirical evidence, the logic, and the expertise dictate the causal relationships among the variables that you have in your model. So if you revisit all of these actual paths, when you're running these regressions, what you have to be thinking about is, in the background, yes, we're looking at correlations, but what we're actually saying is that these variables are actually causally related. And that's mediation in a nutshell. I want to pause and see if there are any questions. The questions you guys asked, by the way, were really spot on, so thank you for those. But I'll move on to moderation next. So moderation is really about the degree to which an association between a predictor and an outcome, the independent variable and the dependent variable, using those interchangeably, right? Predictor, independent variable, or IV, outcome and dependent variable, or DV. How that association changes as a function of a third variable called a moderator. Now, this might sound a lot like mediation, right? Didn't I just kind of say the same thing about how a third variable, changes the association between two variables? Yes, but it's actually a lot different. We'll see how. This moderation is quantified by regression coefficients, and what we have is something called an interaction term, and I'll talk about that. But basically what you have is you have the link between one variable and an outcome, a moderator variable and the outcome, and then the interaction between the predictor and the moderator. And we'll talk about the technicalities of that, but basically you end up with three predictors, the IV, the moderator, and their interaction. So keep that in the back of your mind, and we'll come back to it. Excuse me. So with moderation, what ends up happening is that the strength of the original effect between the predictor and the outcome can change as the moderator changes, or the direction of the effect can change. Now, this is unlikely in practice, but that's a story for another time. There's a really good article by Wisman and McClelland that talks about why the directions of effects don't really change in social science. I don't have too much time to get into that, but it's actually a very interesting article. I recommend reading it. And in fact, I talk about an example next using a figure from Wisman and McClelland. So I adapted this figure, so if you go to read that article, it's a little bit different, but the point remains the same. So it's important to keep this in mind what we're looking at is, you've got 5 different lines, and it's like, what the heck is going on here? So what we're looking at is, again, keep in mind that what's happening here is this statement here is very important. The degree to which the association between a predictor and an outcome changes as a function of a third variable, right? So the third variable here is f, and f has multiple levels, 0, 1, 2, 3, 4, 5. And you see that for each value of f, the relationship between the predictor, which in this case is life stressor severity, the relationship between the life stressor severity and anxiety is different for each level of the moderator, right? So in this example, the moderator is family support. So if you have 0 family support, the degree of life stressor severity is much more strongly, causing anxiety, right? So the more life stressor severity you have, the more anxiety you have, right? As one goes up, the other goes up a lot. But you'll notice that if you have a lot of family support, right? Family support in this case goes from a scale of 0 to 5. So maximum family support, right? F equals 5. The more severe a life stressor has no impact on anxiety, right? So you see that as life stressor severity increases, anxiety does not increase. And everything in between, right? So if you've got medium family support, let's say F equals 3, then, the more severe the life stressor, yes, you do see an increase in anxiety, but it's different than if you have no family support. So that's why family support is a moderator, because it changes the relationship between the predictor and the outcome. So hopefully you're starting to see the difference between a moderation and a mediation. And so I want to emphasize this. Moderation is not the same as mediation. We're not testing whether family support is replacing stressor severity, right? We're not saying, okay, let's look at the relationship between stressor severity and anxiety, and then saying, no, stressor severity goes through family support into anxiety. That's not what we're saying. We're saying that family support changes, not replaces, the effect of stressor severity on anxiety. So the former is moderation, where the family support changes the effect, depending on the level of family support, the relationship between stressor severity and anxiety changes. We're not saying that family support is basically synonymous with stressor severity. That hopefully makes no sense, right? If we were trying to say that family support is synonymous or is an explanatory mechanism for stressor severity, and how stressor severity is positively related with anxiety, then we'd be in trouble, because that would not be supported. So with moderation, it's very important to note that it's difficult to detect moderation effects statistically. And in order to prevent type 2 errors, which is where you fail to detect an effect that is actually real, you have to do what's called purposive sampling. You need what are called jointly extreme cases. What that means is you have to find people who are extreme on both variables. So you want to find folks who have very little life stressor severity and a lot of stressor severity, and you have to find folks with very little family support and a lot of family support. Because if you didn't, then what would happen is you'd find that you have a bunch of people who have, medium life stressor severity, not a whole lot of low stressor severity, and not a whole lot of super high life stressor severity. And you would also find people who have, medium family support, but not a ton of family support and not very little family support, right? You'd find what are called normally distributed variables if you just sampled randomly. But if you actually look for those extreme cases, then that's where you can actually build up enough data in, these ends of the of the distributions to be able to build a robust model. Otherwise, you're stuck looking for data for months and months and months just to try to build up the tails of your distributions in order to get enough data to have a robust model. So that's why you have to get purposive sampling in your data collection phase, so that you get, again, folks with low family support and high family support and low stressor severity and high stressor severity. That way, you can actually get a robust model in place. Otherwise, it kind of tends to fall apart. And you would need, and if you're just doing random sampling instead of purposive sampling, then again, I can't stress enough that you would just need a ton of data to get enough of those extreme cases to be able to get any meaning out of the moderation test. So always important to keep that in mind. And then, okay, so I mentioned what you have are basically three terms that you put in a regression model. One is the independent variable, one is the moderator, and the third is the interaction term. So from a technical perspective, and I don't want to dwell on this too much, there are lots of great articles that cover centering of variables, but it is important to note that centering is a technique that you should always follow when running a moderation analysis. And the first piece is that you basically subtract, once you have all your data, right? You have all your data and you're in the analysis phase, you subtract the mean of each variable from each participant's score. So for example, you have an independent variable, like in this case, stressor severity, and there's going to be some mean for all your participants, right? So you subtract that mean from each participant. So, literally for participant 1, they have some value, in this case on, life stressors, and you subtract that, you subtract the mean from their value, and you do that for everybody. So you're subtracting a constant from everybody's score, and then you end up with a variable that has a mean of 0 when you do that. You're basically shifting the distribution over to where it has not a mean of, say, 4 or 5 or whatever it is, but a mean of 0. And you do the same thing for the moderator. In our case, it was family support, right? So whatever the mean is, you subtract it from everybody's score, and then you end up with what are called centered variables. And those are the ones that you then multiply by each other. So you literally multiply the independent variable score by the moderator score for each participant, and you get a new variable that you've basically created from scratch. And that's that interaction term. That's what this second point is. And in terms of, right, like I mentioned, there's a rationale for centering. And again, this Wissman and McClelland article does a pretty good job of that. They stay away from being too jargony, and they talk about it in terms that regular human beings can understand. It's not just for statisticians. Okay, so just to give a very brief overview of the rationale, it has to do with what are called 0 points, and basically what happens if you don't center a variable, you end up having to interpret effects that have to do with when your predictor, whether it's the independent variable or the moderator, is equal to 0. And if you don't center it, then it becomes a little bit meaningless, because then you would be talking about this very tail end of your scale, when it's like not super meaningful to be comparing things to this point. It is much more meaningful to be comparing things right around the center of your distributions. So suffice it to say that centering is important for interpretation later down the line. And there are other reasons as well, but that's kind of one of the big ones. So I wanted to touch on that a little bit.
So are you recommending that we should always center our variables when we are doing moderation? Okay.
Definitely. And it doesn't, there are reasons that have been debunked for why you should be centering. So some older literature will talk about issues of alleviating multicollinearity. which is not actually an issue that centering resolves, but it does resolve other issues. So it is always good to do, regardless of what the reasoning is. Okay, but all right. So in terms of testing moderation, when we're running a test of moderation, what we're looking for is the difference between two models in terms of the amount of variance that they explain in the outcome variable. So you have one model where you have what are called main effects only, and main effects are basically, is the independent variable significantly related to the outcome? Is the moderator variable significantly related to the outcome? And that's model one. You have those two main effects in there. And then model two, you have the main effects, but then you also add that interaction term. That's where you multiply them by each other. So then you have all three in the model at once, and then you compare that to the first model. And basically what you're looking for is whether or not significantly more variance has been explained. And any software package, including SPSS, will give you a measure called delta R squared, which is the change in the variance explained. And it will tell you whether or not when you add in that interaction to in model two, when you add in the interaction term in model two, whether it is explaining significantly more variance in your outcome than model one, where you just have the main effects. And so, I talked about Sobel's test for mediation. This is kind of analogous to that. And so I want to emphasize here, right, do not test the interaction term by itself. You don't want to just throw in an interaction term and say, oh, look, this moderation term this moderation effect is significant, because the moderation effect actually tests residual variance. So what that means is that you want to already know what the main effects are, and only then does it make sense to test whether or not their interaction is also significant. Okay, so as with mediation, you also get a coefficient, right, a beta coefficient for the interaction term. And what that value tells you is the degree to which the relationship between the predictor and the outcome changes as a function of a 1 unit change in the moderator. So basically, if we go back to this example, you notice that each one of these lines has a different slope, right? So the beta coefficient for the moderator, for the interaction term, is basically telling you, for each change in your moderator, what is the change in the relationship between the predictor and the outcome, right? So in this case, you can see that the slope changes by a certain amount, and that's what that coefficient would tell you is, what is the extent of this? I think in this article is like 0.16 or something is the change in the slope. And so that's how you would describe the extent of that moderation effect. And that's it. That's all I have. Here are the references, like I mentioned at the end of the presentation. Again, like I said, this Wisman and McClelland article is a very sort of user-friendly way to look at moderation effects. Barron and Kenny from 1986. This is basically canon. Everybody cites Barron and Kenny. This has been picked apart over the years. There have been improvements to it. There have been, small changes to it. But it is still a very important article that is really the foundation of all of this. And so it's basically required reading. And then all these other ones are, sort of seminal articles. This McKinnon et al. Article from 2002 has a lot of different versions of testing the significance of mediation effects. It's pretty heady on the math, but they do a good job of summarizing why you should use which version of the Sobel test, more or less. And with that, I want to leave time for questions if there are any, and also note that if you're watching this on our YouTube channel, you can go to this link here to get a copy of the slides of this presentation. And if you end up with any questions, you can contact me. Here's my email, my office, and my phone number. So feel free to reach out.